Just like the wind, we can't see magnetism, but we can see and feel the effects of it. I think a good way to explain just how magnetic neutralization works can best be done in this illustration. Here we have 5 permanent magnets attached to the backside of a coil. The magnetism from those 5 magnets is flowing through the core of the coil. On the piston are 2 magnets. The 2 sets of magnets are set to repel each other. They're placed in a vertical position so we can utilize the force of gravity. Push down on the piston, Danny. Note the repelling force of the magnets. Do it 2 or 3 times, Danny. We're going to apply some DC electricity to the coil, which will stop the magnetic flow from the 5 magnets through the core of the coil. Now we're going to turn off the electricity to the coil and watch what happens. The magnetic flow returns, and there you have it, magnetic neutralization. It's that simple. Let's do that 2 or 3 times, Danny. Using this magnetic neutralization, we're going to demonstrate what we believe to be an over-unity device. In a more simple term, something that produces more power than it takes to run it. The timing cam is 155 degrees. It controls when and how long electricity is applied to the coil per revolution, which is only 43% of the time. Note the coil is activated here and deactivated here. We're using this linkage mechanism to convert the linear motion to rotary. It's good for that, but I feel a poor way to utilize the motor's full potential. When the magnetic force is at its greatest, in this position, this mechanism is at its weakest point of power production, hardly any leverage at all. As it gets to its strongest point, about that position, the magnetic force is getting weaker and weaker. We have these 5 magnets attached to the core of the coil. They're held in place by this bolt mechanism. Each of the magnets are 3 inches in diameter and 1 inch long. We have 2 magnets attached to the piston. These magnets and the ones attached to the coil are repelling each other. When the coil is energized, it neutralizes the repelling force of the magnets attached to the coil, allowing the 2 sets of magnets to come together. When the coil is de-energized, the repelling force returns, thrusting the piston forward. 100% of the motor's output power is produced by the permanent magnets. The coil is only a switch, which when the proper voltage is applied, blocks the magnetic force of the magnets attached to it. There are 2 input forces to the coil. It's under the influence of the permanent magnets throughout each and every cycle. When the voltage from the battery is applied, that in itself creates something called back EMF in the coil, which has to come out. When the voltage from the battery is turned off, there's an inrush of magnetism into the coil from the 5 magnets attached to it. The magnets on the piston are having a profound effect on the coil by inducing their magnetism into it, which in turn creates electricity, and quite a bit of it. Just as the batteries are applying an electrical charge to the coil, so are the magnets. The oscilloscope is just seeing the voltage. It doesn't know where it's coming from, whether it's from the batteries or the magnetic forces on the coil. The motor is utilizing both electrical inputs. We're going to demonstrate this to you now. The coil isn't hooked to the batteries at all, and watch what happens when Danny rotates the large gear by hand. With the motor running, all of this creates some pretty weird waveforms on the oscilloscope. This can make it a little challenging as to which is the proper way to measure the input power from the batteries. We're using the original method for determining horsepower, which is horsepower equals 33,000 foot-pounds of work done in 1 minute. It came about by an average horse being able to lift 330 pounds in 1 minute. We'll be converting that horsepower into watts, with 746 watts being the equivalent of 1 horsepower. The weight being lifted, which is 22 pounds, rises 3.267 inches per revolution. We'll be converting that into foot-pounds, the foot-pounds into horsepower, and the horsepower into watts, which will be the motor's output power. We'll then compare that to the input watts to the coil. Richard Owens will monitor the tachometer and give that information to Danny Little, who'll monitor the input volts and amps to the coil, or switch. During the test, the oscilloscope will take 2,500 readings and capture it. It might look impressive on the oscilloscope, but the real test is taking the 2,500 readings and plotting that information to find the real input power to the coil. Richard, a fantastic machinist, did all the machining required for this motor. Danny, a great engineer, did all the drawings and assembled everything you're going to see. My wife, Wanda, will make sure the rope starts winding properly on the shaft. In a real-life demonstration, I'm sure we'd do this over and over, but for this video, I feel once is enough. You can replay this section over and over if you like. Note the vibration or movement of the motor stand. I feel there's power that can be captured in that. $52.25 RPMs. One thing I want to do here is to demonstrate that this motor will run on a 1 amp fuse. Now that's a fast acting 1 amp fuse. Danny put the fuse in the electrical panel. Now we're going to lift the 22 pounds again using the 1 amp fuse. Now be sure and remember that this motor will operate on a 1 amp fast acting fuse. Now we're going to do the same test, except we'll not be lifting the 22 pounds. The motor will be running under no load. We'll capture this data and compare it to the data we collected while lifting the 22 pounds. $73.55. 73.55 RPMs. Now once again I say, remember I stated earlier that this device would produce some pretty weird waveforms? Well, it gets even more strange. You're looking at the waveform produced by the oscilloscope for the motor test with no load. It displays 1 cycle or revolution of the motor, as recorded. Out of the 2,500 readings taken by the oscilloscope, only 1,360 are in 1 revolution of the motor. The cycle time per revolution is 135.96 milliseconds. You're looking at the entire cycle, including the 43% where battery power is applied and the 57% where it's not. Note, by including the voltage and amps from the entire cycle, the input watts is 25.3. Now that's 25.3. Looking at the chart with the motor lifting 22 pounds, the entire cycle, the input watts is 7.69. 25.3 divided by 7.69 equals 3.289, or 328.9% higher input power. Now, we all know that the motor should require more power to lift the weight than to not lift the weight. Now, if you don't think that's so, just raise your hand above your head. Then pick up 22 pounds and raise that above your head. Now let's look at the chart with the 57% removed and showing only the 43% where battery power is applied and averaged over the entire cycle. The input watts is 22.4. Very little change from 25.3. Now let's look at the chart with the motor lifting 22 pounds and only the 43% where the battery's power is applied and averaged over the entire cycle. The input watts is 4.19. 22.4 divided by 4.19 equals 5.35, or 535%. According to the oscilloscope, the motor requires 535% more power to not lift the weight than it does to lift the weight. In the videos, you can see on the oscilloscope the date and time the tests were taken, both on June the 9th of 2010. The lift test at 14:49 and the no-load test at 15:24. That's 35 minutes apart. And we see this over and over, test after test. Since we're only interested in how much power the coil is receiving from the batteries, let's look at only the 43%. And that's 4.19 watts input while lifting the 22 pounds and 22.4 watts input not lifting the 22 pounds. How am I going to explain all this? You know, there's something called Ohm's Law, which is one of the laws of physics. It states that in a coil, like we have here, that if we know any two of the three values, we can find the third one. In the case of this motor, the two most stable values are the amps and the ohms of the coil. The amps vary a little according to the speed at which the motor is rotating. The ohms of the coil is constant, never changing. It's 10.6 ohms. After much testing, we've noticed that if we adjust the voltage by as much as 2 or 3/10 of 1 volt, it affects the voltage displayed by the oscilloscope. It affects it drastically. By using Ohm's law, I think I can prove that the voltage displayed by the oscilloscope may possibly be wrong. Either that or Ohm's law is wrong. First, let's look at this video. In a simple way, I want to demonstrate how both the voltage and the current rise and fall over time in the coil, and that it's not constant. Using analog gauges instead of the oscilloscope, I think, will give a clearer picture. Now, it's true we have 45 volts available to the coil, but due to the electricity being turned on and off, the coil doesn't have time to consume it all. Now, I'm going to have Danny just rotate the cam there up till it contacts that proximity switch, and it's going to energize that coil. Just do it a couple times there, Danny. Okay, that's it. He's going to do that on and off real fast. And Now I'm going to show those gauges, and just do it there once, Danny. Do it again. Okay, now you can see how the voltage and the amperage is rising at the same time. And now, there it is with the motor running. Note how both the voltage and the current rise and fall at the same time, and that by turning the electricity on and off, it never blows the 1 amp fuse. According to Ohm's Law, 45 volts going into a 10.6 ohms coil would produce a current of 4.24528 amps. And it would, providing the electricity supplied by the batteries was constant. What we have here is the data from the oscilloscope of the test done with the motor running with no load. I've picked out this portion where it shows the voltage reading from 44 to 44.8. Note the voltage I have colored blue, the amps in green, and the watts in red. Now you just saw the video of the analog gauges where it displays how the voltage and amps rise and fall at the same time, and that they were in proportion to each other. As the amps went up, the volts went up. As the amps came down, the volts came down. But we have Ohm's Law to deal with. Remember, if we know 2 of the 3 values, we can find the third one. Remember that? Here we have the same data, only I'm showing a portion using Ohm's Law, which is one of the laws of physics, unchangeable. Whatever explanation is used for this, it has to be within the laws of physics. The section with the voltage in blue is according to the oscilloscope. It defies the laws of physics. The section with the voltage in black is according to Ohm's Law. 0.4 amps times 10.6 ohms equals 1.696 watts. In this section here, according to Ohm's Law, 44.8 volts divided by 10.6 ohms of the coil equals 4.226 amps. Yet the oscilloscope shows 0.4. Are you beginning to understand what a time we've had in determining just how to check the input power to the coil? Well, we decided to stick with Ohm's Law, which is unchangeable. Be sure to watch the video called Motor Simulation. I think it really sends this message home. What you're seeing here is also true in the test with the motor lifting 22 pounds. Here we have a portion of the test results while lifting 22 pounds. Again, the volts in blue are according to the oscilloscope, and the volts in black are according to Ohm's Law. 28.8 volts divided by 10.6 ohms equals 2.72 amps. Yet here the oscilloscope shows 0.4. And here, according to Ohm's Law, the volts should be 4.24. Now let's look at lifting the weight, showing only the 43% were power from the batteries applied, as recorded by the oscilloscope. As you can see, the percent of unity is 169. Note that blue is amps and gold is volts. Let's view the chart in full screen. Note how the amps climb slowly here, appears to level off here, and then falls back down here. The volts appear to rise way up and out of proportion of the amps, which in turn makes the watts or input power do likewise. To me, this is a false representation and defies Ohm's Law. Again, this is as recorded by the oscilloscope. Now let's look at the same chart, only this time using Ohm's Law, which is one of the laws of physics, which is unchangeable. Again, blue is amps and gold is volts. Let's look at the chart in full screen for a better view. Again, we have the amps rising up a little, leveling off here, and falling down here. Note how the volts follows the same path as the amps. Rises here, levels off here, and like the amps, falling down here, which in turn makes the watts or input power do likewise. Now doesn't this make more sense? Remember the video showing the voltage and the amps rising and falling at the same time, in perfect harmony, not defying Ohm's law, which is one of the laws of physics? Also note that by using Ohm's law, the percent of unity is 241. 7.07 watts output minus 2.94 watts input equals 4.13 watts of excess power. If this device can produce 4.13 watts of excess power, I believe that by using this same technology, magnetic neutralization, a device could be made to produce 4.13 trillion watts of excess power. Be sure to watch Motor Simulation. Here we have an electronic automation controller. With it, we're going to simulate the motor running, lifting 22 pounds at its optimum speed. Just like the motor, 43% of the cycle the power is on, and 57% of the cycle the power is off. Everything's the same as the motor, except there are no magnets. This will allow us to see what effect the magnets are having on the coil. We'll see the voltage from the batteries with the small bit of back EMF. The motor, while under load of lifting 22 pounds, will operate on a 1 amp fast-acting fuse. In this simulation, the 1 amp fuse will blow. And I want you to watch for the fuse to blow. Danny, turn on the battery power. Okay, you could see the fuse did blow. We've replaced the 1 amp fuse with a 3 amp fuse. Now we're going to turn on the power to the coil and watch. The contacts in this relay are rated at 28 volts DC. Danny, collect the data before this relay burns up. And it will burn up. Now as time progresses here, you're going to see smoke come from that relay, and it'll eventually just burn up. Now watch the amp meter there and the voltmeter. As you can see, the voltmeter jumping up to 36 volts. And the amp meter there went to, well, you can just read it for yourself. I smell that thing burning? Can you smell it? All right, let's watch close and watch for smoke to come up there, Danny. We should be able to pick up on this video here. Oh yeah, I can smell it. Too bad you can't pick up on the smell in the video. Now the prototype motor itself has been running on the same relay for many, many hours over the past few months. Again, the only difference here is the magnets. Is it smoking? Yeah, Danny can see the smoke over there. I can't see it from here. Boy, you can smell it. Takes a little longer to burn up with the cover off of that relay, don't it, Danny? We've burned up, I think, 4 of these prior to this one. Like I said earlier, our motor, or the prototype motor, which is actually motor number 1 here, that motor is run on the same relay for many, many hours over the past few months. And the only difference being the magnets. It's getting ready. It's burned up already, ain't it? Sparking a little bit. Well, I saw that. There it goes. Do you see the smoke come? It's gone. See, there ain't no voltage or nothing hardly coming through the thing. See, there's nothing getting through there now. That relay's shot. Even though it's still going, the contacts are burned up, aren't they? No power going through it at all. Didn't take long to burn it up, did it? You can turn. Hey, wait a minute. Right there it goes. I can see smoke going right there. can't hardly see it there. That gray and stuff behind, but it's gone.
Yeah, it's gone now.
Yeah, there's nothing there. Sparking every once in a while. Nothing getting through. This will probably be more interesting to those persons having an interest in over-unity and things of that nature. To some, probably most, this may be a little, or maybe even a lot, boring. Here we have the results for the motor simulation test. Now, I'm not going to try to explain any of this. Quite frankly, I don't know how. I'm just going to report the findings. You're looking at the chart over the entire cycle as recorded, both the 43% where battery power is applied and the 57% where it isn't. Like the other charts, the amps are blue, volts are gold, and the watts is green. Let's look at it in full screen mode. According to the oscilloscope, the highest volt reading is 24. Yet if you noticed carefully in the simulation video, according to the voltmeter, the highest reading was 38. Here we're looking at the same chart, except only the 43% where battery power is applied. Again, according to the oscilloscope, the highest volt reading is 24. Yet if you notice carefully in the simulation video, according to the voltmeter, the highest reading was 38 volts. The voltage had to be greater than 28, for the relay contacts are rated at 28 volts DC. In the video, you can notice how the plastic base around the contacts started melting immediately after the voltage was applied. The video is unedited. I wanted it to be viewed in its entirety. It didn't take much time to destroy the relay, yet the motor has ran under load and under no load for hours and hours over the past few months, and on the same relay. The only difference is, in the simulation, there were no magnets, and of course the motor does have magnets. Now here you see the 43% portion of the cycle data. Note the highest volt reading is 24. This is the only reading that is 24. Most, as you will see, will be 22.4. I'm going to scroll down here and let you see the data for the 43%. Again, according to the data collected by the oscilloscope, this relay should not have burned up, yet it did, and in very short order. What you're looking at now is the same data according to Ohm's Law. You can see the numbers for yourself, and like I said earlier, I'm not going to try to explain it, just report. I really don't have a clue as to what's happening here. I know there's people out there that probably do, but I don't. I'm 64 years old, and for the last 42 years I've been in the manufacturing business. During that time, I've designed and built all kinds of automated machinery. The two men in the video and myself have a combined 82 years experience of doing that, and neither of us has seen anything like this. I feel replication is very important. How easy can a device be produced or better yet, reproduced. Here you see two motors. Motor number one, the one on the right, was made from our prototype. We just placed it on this nicer platform. Motor number two we produced with no difficulties. It performs just like motor number one. Hey Danny, turn on both motors. I tend to think that most people are under the impression that an over-unity device must somehow break the laws of physics. This device doesn't even bend the laws of physics, let alone break any. We've spent more time checking the input power to the coil of this motor than it took to build the motor itself. I've sought help from 4 individuals. Professionals in electric motors and electronics, people able to use oscilloscopes who should be qualified to determine how to check the input power of this device. I got very different answers from all of them. One stated this wasn't an over-unity device. The statement he used in describing why it wasn't an over-unity device in itself defied the laws of physics. One of those 4 individuals agreed with me. He's the only one who's actually seen the motor in person and has done so 3 times, spending several hours each visit. He's an electronic engineer and has even taught it in college. He stated that he didn't understand exactly what was going on and that he had never seen magnets used in this fashion, and that probably no one else has either. The others are engineers also, but have only seen videos and information from the oscilloscope. Then I got to thinking about how when we were building this device, that it seemed for the longest time, no matter what we thought was going to make it all happen, turned out to take us in the opposite direction. 180 degrees from where we thought it would. I mean, we were so sure. Then I asked myself a couple of questions. Has anyone ever checked the input of an over-unity device? I doubt it. Do they know exactly how it should be done? I doubt it. By using what has been the standard method, just maybe they'll find themselves 180 degrees in the opposite direction to how it should be done. Is this an over-unity device? Well, I think so. If not, do I believe it's possible for mankind to come up with an over-unity device? Yes. And if that should happen, I think it'll be through an accumulation of knowledge over time. One person adding to another's work. People having the same frame of mind, working together to make it happen. People who are willing to share their knowledge. How did I come up with this? And where did it come from? Who gave me this information? What has till now seemed impossible, kept secret from the foundation of the world? In Matthew 19:26, it states, "But Jesus beheld them and said unto them, With men this is impossible, but with God all things are possible." And in Jeremiah 32:17 it states, "Ah, Lord God, behold, thou hast made the heaven and the earth by thy great power and stretched out arm, and there is nothing too hard for thee." Now in Genesis chapter 11, verse 6, "And the Lord said, Behold, the people is one, and they have all one language, and this they begin to do. And now nothing will be restrained from them which they have imagined to do. Now that word one means united or alike, to unify or collect one's thoughts. And the word imagined means to plan or to think. Now sometimes we may think it's our imagination, when actually it's God putting something in our minds. The imagination, the greatest nation of all. Exodus chapter 31, verse 1. And the Lord spake unto Moses, saying, verse 2, See, I have called by name Bezaleel, the son of Uri, the son of Hur, of the tribe of Judah. Note, he was called by name. He didn't volunteer. Verse 3, And I have filled him with the Spirit of God in wisdom and in understanding and in knowledge and in all manner of workmanship. Now there's an example of God instantly putting knowledge into a man's mind. Verse 4, To devise cunning works, to work in gold and in silver and in brass. Verse 5, And in cutting of stones, to set them, and in carving of timber, to work in all manner of workmanship. Now God has people for every type of work to be done. Like in Daniel 1:17. As for these 4 children, God gave them knowledge and skill in all learning and wisdom, and Daniel had understanding in all visions and dreams. Now back to Exodus 31, verse 6. And I, behold, I have given with him Aholiab, the son of Ahishamach, of the tribe of Dan, and in their hearts of all that are wise-hearted I have put wisdom, that they may make all that I have commanded thee. Verse 7, The tabernacle of the congregation, and the ark of the testimony, and the mercy seat that is thereupon, and all the furniture of the tabernacle. Verse 8, And the table and his furniture, and the pure candlestick with all his furniture, and the altar of incense. Verse 9, And the altar of burnt offering with all his furniture, and the laver and his foot. Verse 10, And the cloths of service, and the holy garments for Aaron the priest, and the garments of his sons to minister in the priest office. Verse 11, And the anointing oil and sweet incense for the holy place, according to all that I have commanded thee, shall they do. In the next 8 verses, Moses is repeating what God had told him in the above verses. Note he tells what it is these 2 men are to do with the wisdom, understanding, and knowledge that God gave them. Exodus 35:30, And Moses said unto the children of Israel, See, the Lord hath called by name Bezaleel the son of Uri, the son of Hur, of the tribe of Judah. Verse 31, And he hath filled him with the Spirit of God, in wisdom, in understanding, and in knowledge, and in all manner of workmanship. 32, And to devise curious works, to work in gold, and in silver, and in brass. Now that word curious means imagination, invented. Verse 33, And in the cutting of stones, to set them, and in carving of wood, to make any manner of cunning work. Verse 34, And he hath put in his heart that he may teach, both he and Aholiab, the son of Ahishamach, of the tribe of Dan. Teach others Yeah, pass along this trade. Verse 35. Them hath he filled with wisdom of heart, to work all manner of work, of the engraver, and of the cunning workman, and of the embroiderer, in blue, and in purple, in scarlet, and in fine linen, and of the weaver, even of them that do any work, and of those that devise cunning work. Teach others, just like Bezalel and Aholiab. I feel this is exactly what has happened to me. Now I hope after viewing the videos you feel as though you've been taught. Thanks for watching, and if you've made it to this point, I sincerely thank you.